In today's video, we are going to be looking at the relationship between triangles and seeing whether or not they are similar to each other. Now, the word similar mathematically means the same shape, okay? So that means the same shape. Okay. So could be a different size, but they will be the same shape. And to determine whether they are the same shape or not is whether or not they have the same exact interior angles measures. All right, so we're going to look at these two triangles and see if they have the same exact interior angle measure and to be able to determine if they are similar. All right, so we have triangles ABC, and then A prime, B prime, and C prime. This little notch here, that's called prime, okay? So we know that there are 180 degrees in a triangle, okay? So if we know that there's 180 degrees in a triangle, we can find this missing angle here by figuring out this equation, right? X plus 48 plus 72 equals 180, right? But a quick way to do that is just use your calculator. You know that there's 180 degrees in the triangle, and so you just have to subtract these two angle measures to figure out the missing angles. So 180 minus 72 minus 48 is 60 degrees. So that means this angle measure is 60 degrees. All right. And also, we could do that with this triangle as well. So we do, again, 180 minus 60 minus 72. All right, so 180 minus 60 minus 72 is 48 degrees. All right. So we take a look at the angle measures. We have a 60 here, right? 60 here, 60 here, 48 here, 48 here, 72 here, 72 here. They are similar triangles, okay? So our final answer is A, B, C is similar. That's the symbol for similar to A prime, B prime, C prime. All right. Both are 60, 48, 60, 48, 72 degree triangles. All right. And maybe I should have put in the triangle symbol in front. Okay, right there. So triangle ABC. So you got to be careful. Yep, you draw a little triangle instead of, because you could interpret that as an angle as well. All right, so triangle ABC is similar to triangle A prime, B prime, C prime. All right, so we determined these two are similar, but their lengths, their corresponding sides are not congruent, right? You notice AC is a lot shorter than A prime, C prime. All right. And also a quick pro tip. If you have all three of these angles right here, you just see that there's 72 and 60 over here, 72 and 60 over here. They're going to be similar. Okay. You don't even have to find the third angle. All right. So it's a quick pro tip if you want to get to it quicker. So let's take a look at these two triangles. All right. Again, A, B, C, A prime, B prime, C prime. All right, this one is not as easy to determine right away. We know we can find this angle right here, right? We can find that angle right there, right? Let's do our 180 minus 99 minus 37. And we notice it is 44 degrees. All right, so I look at all these angle measures, right? 99, 44, 37. There is no 43. So it doesn't really matter what these two angles are. These are not going to be similar. All right. They have to be the same exact angle measures. So triangle ABC is not similar to triangle A prime, B prime, C prime in this case. Okay. And if you want to provide a reason, their corresponding angles are not congruent. All right, so that would be a nice little explanation to show why they are not congruent, because these angles are not the same. Okay, so one way to determine if triangles are similar is by looking at their angles. Another way is to see if that you have all their if you have their corresponding side lengths and see if they form a proportion. So let's take a look at a couple examples of those. All right here. Okay, so it says triangle KLM is similar to triangle NOP. So it's telling us it's similar. Find the measure of side NO, round your answer to the nearest tenth if necessary. So when you have triangles that are similar, their sides are proportional to each other. Okay. So that means ML and PO are the relationship between ML and PO is going to be similar to 16 and the LK and ON. All right, so let's form our proportion. So we have 11.7 over 16. So we have I'm just going to write it out first. We have ML and LK. That's going to be proportional to PO and ON. All right, so we take a look at the small triangle first. 11.7 over 16 is equal to 36, and we don't know the length of this, so we're going to call it x. So 36 over x, and this is our proportion, right? And how do we solve a proportion? Is by cross multiplying. So we multiply 11.7 times x, which is 11.7x. And we change colors for this. 16 times 36. I don't know what that is off the top of my head. 16 times 36 is 576. Leave that number in your calculator. You're going to need it because we're going to divide both sides by 11.7. Okay, divided by 11.7. And you get, whoa, long number, but we're rounding to the nearest tenth. So it's about 49.2. So my x is about 49.2. But for my final answer, I don't want to put just x because you could call this any letter. It's going to be ON. The measure of ON is about 49.2. Okay. Or sometimes you'll see a little line segment atop of it. All right. 49.2. All right. So these would be acceptable answers. All right. I would avoid using X because you could call that any number unless you label the diagram, but I prefer this. Okay. So these sides are proportional, and which makes them similar. All right, let's take a look at another. Oop, oop. All right, so we have triangle BCD is similar to triangle EFG. Find EF. Okay, now this is a little tougher to see where they are similar at. And they also labeled this diagram for us. They wrote the X in. That's very nice of them. Round your answers to the nearest tenth of necessary. It looks like this rotates, right? It looks like it rotates over here. So this, right, is corresponding to EG. So DB is corresponding to EG, and BC looks like it's corresponding to EF. So if you just kind of picture this rotation all the way to here, that's how this would work. I want to make sure I have enough room for my proportion. So I'm going to write BC. Yeah, you know what? I'm going to start with DC, right? Just start with the smaller. So I'm going to smaller triangle first, 19 over 34. So DC over DC over CB. All right, is going to form a proportion, right? This is going to rotate all the way over here to 60 over X, right? So GF over GF over EF. All right. And you don't have to really write this first step, okay? But I just want to show why it's corresponding and how this is set up in the proportion. All right. So we have 19 over 34 is going to be proportional to 60 over X. Cross multiply. So 19X. 34 times 60. Let's see. 34 times 60 is 2040. Oof. Big number. Divide both sides by 19. Leave that number in your calculator. Don't delete it. 107.4. 107.4. Okay, what's 107.4? EF, it looks like. So my answer is going to be EF is about 107.4. All right, we don't have any units in this case, but that's about right. All right, so just a quick recap. Okay, similar. Similar means they are the same shape, not necessarily the same size. All the angle measures in similar figures are going to be congruent. Okay, and this corresponding side measures are going to be proportional. Okay, so that's it for today's video. Thank you for watching, and always remember, whether you're solving for X or Y, always give math a try.